Hey everyone, welcome back to the lab. In this video, we're going to be doing another deep dive into F# HTML benchmarks, this time focused on rendering deeply nested pages. So for the past several weeks, I've been exploring server-side rendering with F#. In the process, I've tried several rendering paradigms and compared their relative DevX and performance. These are different kinds: HTML templates with Scribon, which is a templating framework, raw HTML string interpolation, and then HTML DSLs with Giraffe.ViewEngine, which is domain-specific languages. In my previous performance benchmarks, we've largely been comparing rendering workloads consisting of what I call long, shallow pages. These are things like long lists, tables, but relatively simple markup. So basically we've got a fake HTML page, and you can think of these as like the HTML tags. And so we'd get like a table, we'd have, its header bar here, and then we just render a bunch of items down this way. While this is a good data point to have, it's actually not that realistic for typical HTML rendering patterns. In most cases, if you have a list, you won't be rendering more than, say, 100 items at a time, and usually there's only going to be 1 or 2 lists per page. A much more common workload that this benchmark misses is the combining of multiple subcomponents to build a page. Essentially, every page is built of multiple subcomponents. This might be a navbar, some main content, a footer, maybe some sidebar stuff, etc. And further, those may be composed of their own subcomponents, like buttons or formatted sections, link groups, etc. This means that a far more common workload than rendering a single large list is to combine multiple nested subcomponents together. And so this is kind of what this looks like. I'm calling it like a short deep page. And so instead of having all the items down here, you might open, let's say, a div, and then you'd have things inside the div. And then that might have its own subcomponents here that you'd render kind of this way. And so we're not building a page down on things that are the same level. We're actually nesting them quite far with a bunch of these different trees of nested subcomponents. I'm calling this rendering workload short, deep pages. This is an important aspect to measure, not just because it is far more common and prevalent in real-world apps, but also because it forces our underlying frameworks to act in a different way. When you have a single large piece of data to render, you can do all sorts of optimizations based on the landscape of that data. But when you have multiple subcomponents of which you do not control their output, you now have to be a lot more dynamic and typically non-optimized in how you handle them. As we'll see in the rest of this post, this difference is significant. A quick shout out to this user in F# on Reddit for pointing out that this is a common HTML rendering perf issue. They mentioned this as part of the F# version of Blazor here, Fun Blazor, in which they're using computation expressions, and those computation expressions don't handle nesting very well. And I figured this didn't apply to some of the rendering patterns that I was using, but I was actually kind of wrong. So shout out to them for mentioning this. And so in this post, we're going to explore this new workload. The main question we're trying to solve is how do different HTML rendering paradigms handle deeply nested pages, or at least handle rendering those deeply nested pages. Okay, and so here's the summary answer. So Giraffe.ViewEngine absolutely slays in the deeply nested category. This is likely due to its optimized string pipeline. In memory, it's building up its representation of the HTML using lists, which is very fast. F# is heavily optimized to using lists. A lot of languages are. So doing the actual buildup in memory is quite fast. And then it's followed by only a single string translation using string builder pools, also fast. So I think there's multiple things going on here. The first is the single string translation, where we only have to convert all of this stuff into a string at the very end, and strings are always notoriously expensive. And then the other thing is when we actually decide to incur that cost, which is only once per page, theoretically, we're doing that using a string builder pool, which is also theoretically very fast at this thing. And because it's pooled, you, again, theoretically don't incur the cost of actually building a new string builder every time. So heavily optimized string pipeline that actually works incredibly well, as we'll see in the results. Now we compare this to the other paradigms, so raw string interpolations, or template bindings, where you're using some form of dynamic string concatenation at every intermediate join. And we can see how this approach leads to much more expensive string operations on each render. So like these string interpolations and template bindings, they're dealing in strings mostly. Like, these template bindings, they'll probably have some intermediate form, but if you're trying to nest these templates, like you have to do this like nested parsing, and then when you actually fill it with data, like you have to, depending on how you're combining them together, you either moving the intermediate representation back, or the way that I've been using them is basically turning it into a string and then putting it back into the parent template, if you will. And this is meaning that at every intermediate level of nesting, you're incurring the cost of this string concatenation, which we know is very large. So you can imagine that for every, nesting, we'll call that in, you're doing in string concatenations, and these get increasingly more expensive because the blobs that you're combining are larger and larger as well. So for simple pages, this likely won't affect your decision, but if you're building complex pages with lots of nested components, this may be something to keep in mind if performance starts to become a problem. So we can see at 10 items, which is probably most very simple pages, if you just got like a nav bar and some buttons and stuff. Giraffe.ViewEngine finishes quite fast in just some nanoseconds here, but it's still 2.5x faster than the raw string concatenation, which again beats Scribon templates and my previous benchmarks. So that's already significant, but we can see that this isn't much time at all, so it doesn't really matter. But I think it's interesting as we go down that we start to see that the raw strings are just doing much more work as you nest further and further. And so we get, 16x faster, 33x, 112x, 166, 217, 740, and then up to 1700 times faster for 5,000 deeply nested items. Now, you probably will never do this, but I think for sufficiently large web apps, you could probably easily fit in the 100, 200, 500 range. And I think at scale, this could definitely be significant for you for spending, this much less time rendering a given page, especially if you're doing a lot of server-side rendering and kind of like the pathways that I'm thinking about today, which is more going the HTMX route where we're doing a lot more rendering server-side as opposed to on the client side. So those are the high-level results. In the rest of this post, we're going to be diving into the benchmarks to explore further how we got these results. We'll go into the benchmark setup, the detailed results here, and then the benchmark code. All right, benchmark setup. So similar to my previous benchmarks, we'll be building up example HTML pages using various paradigms. Here, we are only comparing raw strings with Giraffe.ViewEngine because I couldn't think of a native template paradigm I would use for nested components. Typically, I just use simple interpolation for them. Yeah, and a lot of templating languages, they allow you to do it's easy to do the for each loops, and that's what templates are really good at. Some of them can do some conditionals okay. But for nesting things, they often will do partials, but these partials aren't type safe at all. And so I kind of tend to stay away from them because even though they might be a little bit faster, it's I can't just control click into them and see where they go. And so often the way that I use this is templates for different components, but then I string interpolate them together. But of course, this leads to kind of the performance problems we're seeing here, where string interpolation, at scale with deeply nested pages is a problem. So for raw string, basically what we're doing is we're building up HTML with raw strings. For subcomponents, we utilize string interpolation to combine the HTML. So you can imagine that we're building a nav bar, we just build that raw HTML string there, and then in our page, we're hey, go render nav bar with, here's my props, and it just kind of puts it back, and we just build our string that way. So for Giraffe.ViewEngine, we're using the HTML DSL, which uses nested lists to build up a representation of the HTML before rendering it all to a string at the end. And so basically the way this looks is just a bunch of nested functions, which return lists and lists of stuff. And as we saw earlier, that's quite fast. So for running and analyzing the results, we're using benchmark.net and a free Replit instance. The benchmark source code and link to Replit is available in the benchmark code section at the end of this post. The workload we're comparing is building up deeply nested HTML pages. Similar to our previous benchmarks, we're creating a large list of randomized strings using GUIDs and then rendering them in a table. The difference here is that instead of rendering a true table with rows, we're actually going to render everything as nested divs. So you can imagine it's still if you were to render this in HTML, it still look like a list, but we're just doing this a little bit more expensively, I guess, in which we'd have an outer div for our item 1, and then we have an inner div with our item 2, and you can imagine this keeps going this way for, all the 5,000 items that we're going to be rendering. This gives us a very simple framework for rendering deeply nested components. Detailed results. In this section, I'll share the benchmark.net outputs for each run of size n. So at 10 items, Giraffe.ViewEngine in 19 nanoseconds, which is 2.5x faster than raw string at about 0.048 milliseconds, which is about 48 nanoseconds. Here's the benchmark.net. At 100 items, we see Giraffe.ViewEngine 0.12 milliseconds, which is 16x faster than the raw string. At 200 items, Giraffe.ViewEngine in 0.231 milliseconds at 33 times faster than raw string. 500 items, Giraffe.ViewEngine in 0.540 milliseconds, so about half a millisecond here, and 112 times faster than raw string here. I mean, you can really see that like raw string is getting slow at 500 items nested. And, you know, ideally we're going to be rendering our pages in about 100 milliseconds or less, because we don't want to be waiting on the server for very long, especially when we're rendering UI, because this means that the user is like waiting on this. And users typically like will wait 200 milliseconds is like snappy. If it's under 200 milliseconds, there won't be a problem. But as you get over 200 milliseconds, now things are going to start feeling very slow. And so we want to be under 100 milliseconds. But if you're spending 60 milliseconds on just the rendering part, now you're going to start hitting the kind of limits of like how much payloads are you sending down, what's the network latency and stuff like that. That can easily push you over in non-ideal situations. So this is, you know, still reasonable to do, but it's like becoming unreasonable in speed. So for 800 items, Giraffe.ViewEngine is just over a millisecond here, and it's 166 times faster than raw string at 200 milliseconds. And again, this is just slow. We don't want to do this. And obviously this isn't necessarily what your server will be running on, but so you have to test it on your own. But, you know, even on this like tiny instance, like that, we probably don't want this. At 1,000 items, Giraffe.ViewEngine in 1.6 milliseconds and 217 times faster than raw string. And then, you know, we're getting into the ridiculous range of like 2,000 items. Giraffe.ViewEngine still does it in 3.3 milliseconds, 740 times faster than raw string, and we're up in like the 2.5 second range, which is quite slow. And then finally at 5,000 items, Giraffe.ViewEngine handles it very well in 8 milliseconds. It's 1,700 times faster than raw string, which is up in like the 14-second ranges, which like you definitely don't want to do. Your user's quitting the site. They think your thing's broken. Yeah, don't do this. Okay, now for the code. So you can just get the replit here, and this is exactly what I used to run the benchmarks. So you can come over here, look at the code, mess with it, run your own benchmarks, stuff like that. And then I've just pasted it out here, so you can kind of get a feel for this, especially if replit's not working or something. And we won't go into this too deeply, but I'm just going to show you kind of like how we're doing the rendered nested divs. So basically for the raw buildup of the divs, we're passing in a list of items, and then we're just building a recursive function here that basically says like, hey, if there's like an item at the front of this list you gave me, I'm going to build a div with my item, and then I'm going to call myself again with the item skip one. So use my list, just don't have the first guy in there, and that's how we're kind of iterating over the list. And if there's none, we're just going to print out end, and then that'll collapse the recursive function back up. And crucially here, you're seeing that like we're going to be doing a string concatenation right here using the string interpolation right here. And so this is where, you know, all this slowness is coming from, because at every level we're incurring the cost of string interpolation. And then at every level, this blob is going to get bigger and bigger and bigger, and then we're trying to interpolate that each time. So that's kind of where we're getting that. I don't know if it's exponential. I should probably graph this thing, but quite slow back off here. Now we're doing the same thing for, you know, Giraffe.ViewEngine as well. So, you know, takes in the same basic definition, which is just an items of string list. This time we're just returning XML node instead of the string, and it's basically the same. You know, we're just saying like, hey, let's try to get the thing off of it. If we don't have it, we're just gonna return the text end. If we do have something, we're going to have our div with the h1, which is the text that we found in there. And then we're going to call ourselves again in order to get the next item and recurse down. And we can see that at every level, you know, we still have the same amount of nestedness as we had at the raw string before. But we're concatenating a list here. There's no string concatenation. This is just a list. We have our first item, and then it's like, hey, we're just going to pop our second item in here. And so there's no concatenation. You know, this is just like a simple string.add, which is, you know, theoretically very fast. And as we kind of prove in the benchmarks, this is much, much faster than the intermediate string interpolations. All right, what's next? So Giraffe.ViewEngine is hella fast. You probably won't be rendering 5,000 nested components like ever, but 500 seems possible with a sufficiently mature web app, and we're seeing significant 100x speedups there. And definitely, like, if you're used to writing in React or like these other kind of like JavaScript component heavy things, like it's very easy to get, a nested tree of at least like 10 or 20 items. And so if you can imagine that like one component might be nested of like 10 or 20 items, it's very easy to see how, a whole page could have a nesting of, you got your nav bar, you got your main page, your sidebar, stuff like that to come up into the low hundreds. So if you're trying to do that server side, definitely might think about reaching for one of these DSLs, or at least for a templating engine that's not relying on this raw string interpolation underneath the hood. Personally, I've been pleasantly surprised with both the ergonomics and performance of Giraffe.ViewEngine and plan to continue playing with it in upcoming projects. And yeah, I haven't built my site with this yet. It's currently just using raw string interpolation, but I have liked it a lot, and so I'm thinking about moving my site over to it, and then also maybe switching Cloud Seed over to it, because even when you're using it, you're not tied to it. So I think it's like a good starting point for most people in the F# ecosystem. So if you like this post, you might also like Build a Simple F# Web API with Giraffe, which will get you started with the Giraffe web framework. If you're interested in using Giraffe.ViewEngine, you can check out server-side HTML rendering with F# and Giraffe.ViewEngine. And then if you're interested in my other benchmarks focused on long, shallow pages, so this is the short, deeply nested pages. The long, shallow pages is kind of like the other dimension, if you will. Then you can check out this post here. That's it for this video. Thanks for watching, and I'll see you in the next one.